In this final video, we'll look into some further applications of consumption-based accounting, which allow us to quantify spillovers embodied in international trade. These applications use the same formula represented in the previous video and isolate out the expenditure and/or the indicator in question for one or more particular countries. Spillovers occur when a country's actions result in benefits to or impose costs on another country, and, as Jorge explained, can be grouped into 4 categories: the direct action of one country on another, transboundary flows between countries, influences through the global commons and global public goods, and influences through trade. The need to consider spillover impacts when mainstreaming the SDGs across the EU was called out in an SDG resolution adopted by the European Parliament in June 2022. This resolution noted that many EU internal policies not only contribute to the implementation of the SDGs, but also have a very high ecological, social, and economic spillover impact on developing countries and vulnerable groups and populations. Input-output analysis is a very powerful tool in quantifying what those spillover impacts are, specifically the trade-related spillovers, since it enables us to connect the economic activity that takes place in the EU to the economic, social, and environmental impacts that are manifested in other countries. As touched on in our last video, input-output tables can be used to assess the economic activity for one country and for many. A global multi-region input-output table contains information on the economic transactions taking place within and between countries, providing us with detailed information on international trade relationships, which we need to understand in order to undertake a spillover assessment. When we partner that economic information with data on various social, economic, and environmental indicators, we can also quantify the impact of that trade activity on the indicators in question. For example, if we know the quantity of greenhouse gases emitted by each sector in each country, data that we can obtain from national greenhouse gas inventory reports, then we can connect those emissions with the products or services produced by that sector and follow them as they make their way from the country of origin to the country of consumption. Or, if we know the number of fatal accidents that take place in each sector in each country, data that we can obtain from the International Labour Organization, then we can connect those fatalities to the products and services produced by each sector and follow them as they make their way from the country of origin to the country of consumption. Said another way, we can quantify the spillover effects associated with consumption in each country and for the products and services provided by each sector. Here's one such example where the researchers investigated negative social spillover effects associated with global textile supply chains, specifically indicators related to occupational health and safety, fatal and non-fatal accidents. Using the EORA multi-region input-output table, they were able to track this spillover effect across 189 countries and specifically studied the impact of consumption based in the EU, with a focus on Germany and Italy, who import clothing, textiles, and leather, primarily from Asian countries. They found that Germany is responsible for around 20% of the EU's spillover footprint associated with textile-related imports. And this figure shows us where the associated workplace fatalities are occurring. We can see the greatest spillover is into China, where 19.2% of the fatal accidents associated with this German consumption occur, followed by India at 16.2%. These imports are also implicated in workplace accidents in Africa, particularly Madagascar and Tanzania. Another way to visualize spillover effects can be found in this figure, which illustrates which countries are net importers and net exporters of an environmental impact, in this case, species extinction risk. This research also used the EORA multi-region input-output table, but this time connected the economic data with information on species extinction risk, which was generated from the data curated in the IUCN Red List of Threatened Species. Now, species extinction risk is very location specific, since many threatened species or near threatened species are only found in one country. Quantifying the extinction risk of the species found in each country and connecting that to the economic activity that generates the threats acting on each species enabled the researchers here to connect the extinction risk to the locations of consumption behind each threatening activity. In this figure, countries have been classified as net importers if their consumption activity has a greater impact on species outside their borders than species within their borders. And these countries are colour-coded orange. With the darker the colour, the higher the level of spillover. Countries have been classified as net exporters if the consumption activity from other countries has a greater impact on species found within their borders than on their own consumption. These countries are colour-coded green. And again, the darker the colour, the higher the level of spillover. The countries colour-coded blue have minimal spillover happening. The consumption within the country is the key consumption activity impacting the species within that country. You will notice that all the EU countries are net importers, meaning that the species that are most impacted by consumption originating in the EU are based in other countries. Another spillover study looked at different environmental impacts associated with the trade of food products into the EU. These three charts have been created using another analytical technique that forms part of the input-output analysis suite, production layer decomposition. This allows us to decompose the impact into the various tiers in the supply chain, which are also known as production layers. The number 1 along the x-axis on each of these charts represents the first point of the supply chain, where the final consumer is purchasing the food product. The number 2 represents the next tier in the supply chain, where the food producer purchases the inputs it needs for production, and so on. The colours in each chart show how the impact is distributed geographically, with each region a different colour. As an example, let's look at the bottom chart here, which shows how much land area is used, in thousands of hectares, to produce the food products that are ultimately consumed in the EU. This chart shows us that closest to the point of consumption, which is on the left-hand side of the chart, land in Africa represents the highest share. But by the time we get to tier 8 of the supply chain, the land use requirement is quite evenly spread between Africa, South America, Asia Pacific, and Eastern Europe and Central Asia. Along all of those tiers, the land use requirement within Europe itself is less than every other region other than the Middle East, illustrating the spillover effect driven by food consumption in Europe to land use across the rest of the world. Our last example of a spillover analysis facilitated by input-output methodology was published in collaboration with the UN Sustainable Development Solutions Network. This study looked in detail at 6 different indicators: 1 economic, which is income, 4 social, so employment by gender, modern slavery, and workplace accidents, and 1 environmental, CO2 emissions. And it assessed the spillover effects associated with the mining sector. This figure shows the impact on these indicators of the fossil fuel and mineral mining that takes place to satisfy consumption based in the EU. Now, some of these impacts might be considered positive. If we look at income, for example, we see that just under 75% of the income generated by EU consumption of mineral products is outside of the EU, which can be a positive social outcome if that income is connected to fair work practices. We can also see that the spillover effect is greatest for the modern slavery indicator, with 95% of the impact experienced within supply chains that originate outside the borders of the EU. And across all of these indicators, impacts embodied in imports into the EU are higher than any impacts associated with supply chains that originate within the EU. This highlights the significance of spillovers embodied in international trade and reinforces the EU Parliament's concerns that any policies that promote the delivery of the SDGs within Europe cannot ignore the very high ecological, social, and economic spillover impacts on developing countries and vulnerable groups and populations. Input-output analysis is a very powerful methodology for uncovering the consumption activities that ultimately create demand for production processes that in turn create the social and environmental impacts that are undermining the natural and social systems that we depend on. Once we can quantify the impact induced by those consumption activities, we can begin to affect the change that is needed to reduce that impact and to live sustainability within the planetary boundaries.